How are you, everybody who is watching this video? I'm very happy to have you, whether you're a national or international student, or whether you're national or international parents, guardians, teachers, maybe a sponsor, maybe you are, I know that you can be a teenager, you can be a graduate, regardless of your status, whether you're national or international students. I would like just to tell you in advance that Olenjolai loves you so much. My name is Sir Olenjolai Moko TAYAI Single. Simply just call me Sir Olenjolai. I'm from Tanzania, the beautiful country in eastern of the African continent. I'm very happy to have you today and have a good news. And let me begin to inform you about the good news that we have is about our online undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolai. Right? Simultaneously, because I'm a mathematics teacher, I would like to welcome you into one of our YouTube channels that's called Online Undergrad Polyinstit of Tanzania in square bracket Olenjolai. Right? So then the next question that's in your mind, what are you doing? What the visions that you have? What the mission? What's your mission? What the missions of Online Undergraduate Polytechnic Institute of Tanzania? What the visions of Online Polytechnic Institute of Online Undergraduate Polytechnic Institute of Tanzania? What the visions, right? That's the good questions. This is our national flag, first of all. I've been called by the Lord Himself that, and He built the characteristics, the gift of teaching in me is just like how He has built it, flying for the birds. Because birds, they don't attend the flying schools, but they fly every day and make the world very interesting and very attractive for the touristy and even for the non-tourists who are just like the normal people who are working in different places. Right, this is the vision that we have in Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Yes, so I just have remembered here that this is here we have another letter which is M. So square bracket OLENJOLAIM. That M has very important meaning for the rest of the life of this online institution. Wow. So first of all, Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, it's an online platform. We don't have a physical institutions right now for undergraduate, we just have online. So we deliver all our contents and our service and our products online. So you have to be well connected with us online, and you have to make sure that you watch those introductory sessions or introductory lectures where we give you the details of how you can be connecting with us or join with us through the entire year. So maybe in 5 years, how can you get connected with us in your lifetimes? Because this is the program for the lifetime. Well, so this is the vision. Let me go the visions of Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. This is the vision and it's an assignment. So the Lord has given me an assignment just to teach, to train, or to incubate, to lead, to mentor, to encourage, and also just to motivate, right? To motivate some group of students who will be ready to extract knowledge from the formal education, formal or informal, education in engineering fields, including fundamental course or modules, and the core modules, or we call them core courses in some of the institutions, to combine knowledge extracted from the classroom instructions with the knowledge that they have to extract it from the whole Word of God that has been written in the Holy Bible, and combine these two knowledges in order to solve real-life problems. That's our main objective, in order to solve real-life problems. I know that what I'm telling you, it might be just like something in your mind that this man is very crazy. I'm not crazy. I know what am I saying, because it's, first of all, it's not my vision, it's not my programs, it's not my institutions. The one who owns the institutions, who the Lord Himself, the Lord of the earth, of the entire earth, is the one who declares everything. So for myself, I have to obey His will for the rest of my life in this program. Well, so our vision has four main parts. The first part, to understand the classroom instructions, which will be focusing on that. The second part, to extract knowledge from the Word of God, which we have special departments that we call the departments of the kingdoms of heaven, where we'll be pondering the Word of God from the Genesis chapter 1 verse 1 to Revelation chapter 22 verse 21. It is possible. Don't worry about that. And then the third part, to combine these two knowledge, and the fourth part, to solve real life problems. We are born to solve real life problems. problems. We are not born to have certificates. First of all, certificates, they don't have any contributions for eternal life. So we are born to solve particular problems, whether small-scale problems, large-scale problems, medium-scale problems, extraordinary large-scale problems. So regardless of the size of the problems, we'll be happy to see our students maybe after several months or maybe a year, 2 years, 3 years, 4 years, they are solving real-life problems. That is our main objective in this platform. That's our main goal. We have some specific objectives that to help you to go through your continuous assessment, to solve your tutorial questions, you see, and also you have another specific objective to help you to pass your final exams or your university exams. So we have so many specific objectives, and the main objective of seeing our own continuing and even graduate and graduate or bachelor students who are solving real life problems from the year community. Doesn't mean that you should solve problems. And I want just to give you a little testimony. Myself, who is talking to you, Sir Olenjolai Single, or simply just call me Olenjolai. I'm a product of what I'm telling you. I'm a product of the classroom, of the knowledge which I've extracted from the classroom instruction or classroom education. And also I'm a product of the informal education that I've been learning a lot of stuff, and even this, I've never studied at University of Dar es Salaam or under the universities which are under the TCU, but I learned it informally. What am I going to teach you? I'm also a product of the knowledge of the Word of God. And also I'm a product of combining those three knowledge, formal, informal knowledge of those two types of knowledge, and I'm solving real life problems. And one of example of real life problems that is the one that I'm solving right now, the one that I'm teaching. You need somebody to teach you in a simplified language, and also to encourage you and open your eyes to see more than what you usually see in your normal classroom institutions. So I think that that's enough. I will be just reminding you and telling you some of the information as days goes on. So in online undergraduate Polytechnic Institute of Tanzania, we have 2 departments currently. And I'm saying currently because this is a lifetime institutions, I tell you. Lifetime institutions. So we have 2 departments. One department is departments of the kingdoms of heaven, where we are going to ponder the word of God, the holy word. Okay? The beautiful word. And also you have the departments of higher engineering and scientific mathematics. Currently we are focusing to mentor, to prepare and to teach engineers and scientists for the rest of their life, right? So then in departments of higher engineering and scientific mathematics, where we are today, we are teaching 12 modules or 12 courses, right? 6 courses for the semester 1 and 6 courses of modules for the semester 2. Don't worry about that we'll be covering steps and you'll be enjoying step to step. So the modules or the course that we have based is called several variables. Several variables, and as an S here, okay? Several variables calculus. Okay? I'm kind of quickly because I want to take you into what I've prepared today for you. Several variables calculus, right? So that's the module of the day, the course of the day. This module is specifically for the second year students, and one of the example which are the main university are in Tanzania, the leading university is University of Dar es Salaam, and all the universities under the TCU, University of Dodoma, Kampala International University of Tanzania, St. Joseph. So all the universities which under the State University of Zanzibar, under the TCU, they learn these modules in either first year or second year. This is the module for the first year semester, as we'll see in the general introductions of this video. And then we are in chapter 1, which is called the function of several variables. Function of several variables. Function of several variables. We have already covered the 3 lecture. Lecture 00, general introductions of several variable calculus. Lecture 1, which is general introductions of general introductions of several variable or functions of several variable. And lecture 2, I told you about the function of several variable itself, right? And then lecture 3 today is I want to teach about the limit of the function of several variables. Remember that if you're a graduate or if you are undergraduate students or bachelor students from A-level advanced educations, right? Or advanced educational system, which I myself also did. We have never learned this stuff during our advanced education, so you have to listen carefully. When I'll be teaching about functional several variables, it's a new concept for all ordinary diploma graduate and also for all the advanced education's graduates, right? So it's a new concept. I met it for the first time when I was in my undergraduate studies at the Dar Institute of Technology for the first time, right? So limit of the function. Again, if you're international students, remember that in Tanzania we didn't discover anything in mathematics. So the mathematics you're learning is universal, right? So don't worry about the name of the modules. It can be called about the advanced engineering mechanics, the advanced engineering mathematics. It can be called the engineering mathematics 1, engineering mathematics. Those are the names. Don't get confused about the names of the module. Get confused and be crazy on the contents of the module. So examine the contents of your modules or your course right now, regardless of the name, and then analyze. That's why that in general introductions of lecture 00, I gave you the contents that I'm going to cover. So possibly you might find that you have to go through 2 modules or 2 courses in order to grasp you and get everything that you deserve to get according to the curriculums of your institutions or college or university, right? So again, before we even just continue, I'd like just to let me just end with a couple of the announcement. The first announcement, I would like just to tell you that we have a library, just like a normal physical institutions or colleges or university do have library. Also, in online undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM, we do have also fantastic library which we can save our students, teachers, mathematicians, scientists, in entire country of United Republic of Tanzania, because we are going to use the curriculums of United Republic of Tanzania. So one of the contents is we are distributing original scientific calculator. This is Casio function 991 FX function FX 991 MS. So it's original, it's cheap. We can ship in any regions of all the 31 regions of United Republic of Tanzania. So you can order it right now. Just read the descriptions below. You'll see the link, and then she'll send you that how much does it cost and what the shipping costs. You just have to pay. We are just servicing our students because we love them so much. Again, the last announcement or last just demo introductions is in case when maybe at this moment when we are starting to take these contents, or maybe later on, when we will continue or at the end or after covering these contents, when you hear from your heart, because teaching the work of heart. So myself, I'm doing what I'm doing from my heart. I'm not doing just to please somebody. So in case you feel from your heart, you want to offer God, the mighty Almighty God, your free willing thanksgiving offering for this program, for the contents or for the service that you've been receiving from Tanzania, from online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, then don't hesitate yourself to send that free willing thanksgivings, because it's gonna support the running cost. We expect you to have more than 500 free videos in our YouTube channel for undergraduate students to educate them. So it means the running cost is high, but our code is greater than the running cost. But in case you feel from your heart, we invite you to do it, to send your free will thanksgiving through 07597453 and 31. So stay focused, stay tuned. Let us go to the business right now. So let me just begin with a quick review of lecture 2. So in lecture 2, basically, first of all, I reminded that when we began our journey of learning function, we have been learning function authority of single variable, right? Functions authority of single variable. For instance, if you have f of x is equal to cos of x, right? Again, so I took you. So in undergraduate education, we take you to the next level, because the real life problems, when we want to model them in mathematics, to have only 2 variables in the functions is not enough. To have dependent and independent variables is not enough. So after long-term research, mathematicians discovered a new field of functions, which we call the function of several variable, functions of several variable, right? Then we categorized it. We say, first of all, we have function authority of 2 variables, right? 2 variables. So in this stage of the function, we say that we have 1 dependent variable and 2 independent variables. So example, I told you that in case you have cos of x plus, let's say that e power 1. So this is the functions of the 2 variables. And we have touched it a little bit in parametric differentiation, if you do remember. So function of the 2 variables. Again, I told you about FCT, these functions, right? Functions of 3 variables. This is common, it's okay for 3-dimensional. So this one is ffx, comma y, comma z. We say that it can be, let's say, cos of x plus e power y plus ln of z. So these are the functions that have one dependent variable and three independent variables. So that's what we've been discussing, and hence we thought about applications in real life, in the issue of the temperature, etc., 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 etc. So today, let me take you in this new lecture today that limit of the functions of the several variable calculus. And in order to understand, we have to recall always this is the style that God has given me to teach you. I have to know the pre-knowledge that my students have. So I'll be starting from there because I have to build the foundations. And remember that according to the notes and the course, yes, the course are set up for University of Dar es Salaam, what they provided in case of limit of two variable, of the functions of the two variables is less than what am I going to provide to you, because I know that these contents will help millions of national and international students in undergraduate. Okay, so let us begin. So before I teach about the limits of the functions of several variables, which will be focused on limits of the function of the two variables, let me begin with limiting of the function, limiting of the single variable, of the function of single variable. I'll be just correcting several times. Limit of the function of single variable. So this one we covered in general calculus, the single variable. So when we covered it, we say that we have two definitions. So in limit, we have two definitions, right? The first definition, we call it informal definition, right? Informal definition. If you forgot, just to go quickly into a playlist called calculus, so that you'll cover all of these concepts in the one of the modules that called calculus, which I taught by using the curriculums of Dar es Salaam Institute of Technology. So informal definition, and here we have a formal definition. So we have informal definition and formal definition. So having formal definitions and formal definitions, then this is a very important concept in mathematics. So let me remind you quickly, just within a few minutes, informal definition of single variable, of function of single variable. Informal definitions of single variable, right? So informal definition of single variable function. Okay, so formal definition of informal definition of functions of the single variable, we told you in calculus that given if the limit, we told you this definition, very important. We told that if the limit of x approaches to a bar of the certain single variable of the single variable function is equal to the limit of right hand side, which you write in mathematics x a bar of f of x, then we say that then limit of the function f of x, which we call the L, exists. Otherwise, the limit does not exist. So this is what we call the informal definition. So the informal definition, we say that if that's the case, we say this one. So we can generalize like this one. That limit as x approaches to a bar of f of x, this is equal to limits as x approaches to a positive of f of x. This is equal also to the limit as x approaches to a, right? X approaches to a of f of x, and this is equal to r, if the limits of the function is existing. And if you remember that the application of informal definition, which we told you, and this secret is still in on. So we have taught you more than 5 lectures of informal definitions. So application of formal definition is to find limit of the function f of x. So that is all about informal definitions. And I solved more than 10 examples in 5 lectures of 5 lectures, yes, 5 lectures, yes, 5 lectures, yes, 5 lectures. So you can access them in the same channel. Okay? So that is about informal definition. So after teaching you about informal definitions, now I can take you into the next level where that now I have to teach you about so this is 1, this is 1, this is 2, and I have to teach about informal definition, just to link it on what you knew in advance. Informal definition of two variables. So we'll be limiting ourselves on two of the function of two variables. Functions of two variables. How can I define? How can I provide the informal definition of the functions of the two variables? How can he provide it? Okay? How can he provide that? So he said that, okay, have to be careful with this. Okay? So informal definition of limit of functions of several variables. Informal definition of limit of function of several of two variables. Okay, so let us write a little bit. Given a function of two variables as f of x comma y, okay, f of x comma y, as x comma y approaches, as x comma y approaches a point, okay, approaches a point of x comma y, okay, approaches a point of a comma b. These are the point, just like a single variable can replace a comma b, but not at x is equal to a, comma y is equal to b. Okay? Then the limit of f of x comma y exists. Okay? So the limits of the x comma y exist. So how do we write that sentence mathematically? So mathematically we say that generally the limit of a function of the two variables, which is x comma y, approaches 2 points, okay, but not equal to those points of a function of the two variables. This one will be given as L. So this is the general definition that you have to bear in your mind. So you cannot see that this general definition is just like what we have here. So here we have a single variable which is only x. Here we have two variables which have x and y. So here x approaches to a. Here x approaches to a and y approaches to b. Right? So then for this case we have also a condition for the limit to exist. The condition, the limit of left hand side should be equal to the limits of right hand side. That's the condition. If they are not equal, then the limit does not exist. We told you. So we go again for the condition, right? Condition of existence of what? Of limit. Because we are going to focus on this and we are going to use it. So of limit of what? Of function of two variable. Okay? So we say that if the limit error of the function f of x comma y exists, right? Then we say that then limit of left hand side, so that then limit as x comma 0, x comma y, is it x comma y? For me, let's check. Limit of, okay. So if that limit exists, let me write here. It will be sounding good. I believe that you're enjoying the beauty of higher engineering and scientific mathematics. Please share this stuff or these contents with your friends. So if the limits L of the functions of x comma y existed, then we say that limit, this is the condition, x as limits as x approaches to a of the function of two variables, which is f of x comma 0 when y is equal to 0, right, of this function, should be equal with the limit. So this limits of left hand side possibly, but this is just not like the previous one, but we can just define. Okay? This should be equal to what? This should be equal to the limit as y approaches to b and the function is f of 0, comma. So this is the very important condition. So literally, if you want to link these concepts with what you knew in advance, this we used to call the limits of left hand side, limits of right hand side. So this limit of left hand side, and this is limit of right hand side. So you can define this as limit of left hand side and this limits of right hand side. However, that in case of the functions of two variables, we don't have left hand side and right hand side because those are the just variables, and those variables you can point them. They are not only relying on the x-axis, because now remember in the single variable we find that the dependent variable y depends on the axis. So it means these points will be lines along the x-axis. For the functions of the two variable, that point will not line along the x-axis itself. So that's why that we cannot say that this left hand side and this right hand side. So this is the limits when x approaches to a, means that when this is the limits as x approaches to a when y is equal to 0, and this is the limits when y approaches to b when x is equal to 0. That's how. And this is the one of the definition that you have to use. So mathematically now, okay, if you want to solve mathematically, we say that given limit, right, as x comma y approaches to a comma b of a certain function which depends on the two variables L, right, like that one, right? We have L. We don't have L comma L, L1 comma L2. So we say that then L exists if what? If the limit as x approaches to a of this function when y is equal to 0, but x is not equal to 0, should be equal to limit as y approaches to b, right, of the same function, but now when x is equal to 0 and y is non-zero function. So this is how we have to think as undergraduate mathematicians. We are going to use this informal definition soon to find what the limit of the different functions, and especially for the rational function. So this is all about 30 informal definitions which you are going to have a focus on. Very important. Keep this focus. It will help you. Because the next lecture will be about continuity of the several variable calculus, also of the functions of the several variables. So also the concept of continuity is just like what I taught you in the theory of limiting, right, as a chapter, as the first chapter of the modules or course called the calculus. So we learned just 3 parts: limit, and just we learned informal. I taught you informal definition, formal definitions, and continuity of the functions along the particular point or along the interval, a certain interval. Okay, so this is about the formal definition, right? Informal definition. So before I take you into the informal, let me give you examples. Examples of what? Examples of function. Examples of limiting of the functions of two variables. So the first example is limit as x comma y approaches possibly to 0, 0, and then our function here we have x squared plus 4y squared then minus xy. So that's one of the examples. Then the second example is a limit. In most cases, we find that the functions used to be rational function. X comma y is equal to possibly 0, 1. And then here we have a function, right? Which might be say x squared y. Okay. So remember also a limit can exist and a limit cannot exist also, right? Okay, so limit as x comma y approaches to 0, 1 of that function. So this is the function now, right? And then the said example can be limit as x comma y then approaches to 1, 1, and here we have sine of x over, then we say that y squared plus cosine of x. Okay, so those are some examples. So we say this is the condition for the limit to exist. So we say that if limit of f of x comma y does not exist, right? Does not exist. So we say then the limit as x approaches to 0 of f of x comma f of x comma x, f of x comma 0, okay, this should not be equal with limit of the function, right, as y approaches to b, and our function is f of x, f of 0 comma what comma y. So this is the condition for the limit of the functions not to exist, right? So very important information. You will see its applications soon and for the rest of your life in OT, in higher engineering and scientific mathematics, right? In case you have any question concerning about what am I teaching you, concerning about whether you understand anything else that you want to communicate, because I want my class to be complete, not incomplete. So normally in my physical classes, I spend 30 minutes to give students to ask you questions. So ask in the comment section, please. I want to interact with you in the comment section of this video. Because that's one of the challenge of online training, that students, they used to ask you so many questions. How can we ask you questions? How can you give our recommendations that we have understood or your lecture is clear? Use the comment sections. That is what YouTube has done a great job to allow you to interact with me and with also other students around the world. Okay? So then that's the case, or that the condition. So now, let me remind you, number 3, that limit, or about formal, you know this, or should know this in advance, formal definition, but if you don't know, just go in the first chapter of calculus that called theory of limit. I have taught you 3 lectures of formal definition of the single variable. So formal definition of limit of function. We have a lot of today. Functions of what? Of single variable calculus. Function of single variable calculus. Single variable calculus. No, single variable. Okay, single variable. Excuse me. So the formal definition, we say that the formal definition, in case of the calculus, we say that given, which used to prove the limit of the function, given limit of the certain function f of x as x approaches to a is equal to r, right? So again, we say that for every epsilon greater than 0, right? There is delta greater than 0. Then we say that absolute of x minus a, absolute again, which that point, should be less than delta. And this implies what? Implies this one. Implies that absolute of f of x minus limit, this also should be less than what? Epsilon. Or some of the books define that 0 less than absolute of x minus a, right? Less than delta. This implies that absolute of f of x minus l, this is less than epsilon. Very important definition. So it is used these applications, just to remind you, applications of formal definition of limit of the functions of single variable is to prove. So remember that application of what? Of formal definition. Formal definitions of what? Of limit of the function. Formal definitions of the single variable of the use of the function is to prove the limit of what? Of the given function. Similarly, the main applications of the formal definitions of the function, of the limits of the function of the single variable, is used to find the limit of the function. Also, the applications of informal definitions of the functions of the two variable is used to find what? It's used to find limit of the function of two variables. So that's the point that you have to remember, right? So then let me go to the first part before this will be the last conceptual part. Then we got the questions, because in some of the session, so I say the first one, okay. So the first part we say that let me teach you about formal definition of limit of function of two variables. Functions of two variables. Okay, functions of two variables. So how can I define this? This is a little bit complex, okay? But we won't use it in case of solving problems. That's better for you to know, okay? So we define like this one. We say that given limit of the 2 point x comma y approaches to a comma b of what? Of the function f of x comma y. This is equal to L, right? The L of f of x comma y exists as x comma y approaches approaches 2 points A, comma B for every real number. For every real number. Epsilon greater than 0. There existing a real number delta approaches to 0 such that absolute of f of x, y, f of x, y minus L, which is limit, right? This is less than epsilon. Whenever what? We clean the next column. Whenever whenever 0 less than square root of x minus a square plus y minus b square, and this is less than delta. Interesting. So you see how the formal definitions of two variable or functions of how formal definitions of limit of functions of two variable is interesting. So you see the way that it is. So we can compare, right? 0 is less than square root of x minus a square plus y minus b square less than delta. This one is equivalent to what we have here. You see? You see how mathematics is beautiful? You see how maybe the wall is built on the foundations. Suppose this is the foundation, and now we are building the wall on top of what? Of the strong foundation. Then again we have the second part, which here it is becomes as first part. You can interchange that this implies this or this implies this one. So the second part we have f of x, y minus L. There's absolute, right? Absolute functions. And that's less than epsilon. This is equivalent to what we have here. So you see, mathematics is not a difficult subject. It's a very interesting subject. It depends who taught you. And depends what were you thinking when you've been learning for it. Because I know in Tanzania, many people, they do believe that mathematics is the national disease. I disagree completely that phrase. I don't believe, I didn't believe, I don't believe, I won't believe. Mathematics, it's a queen of engineering. Mathematics, it's the best way of solving our real life problems. Okay, so this is about 30 informal definition. So let us see that how we can make, for instance, when we give us a certain function, then we have been asked that to express in the informal definition, right? In the formal definition of limit of two variable, limit of the functions of the two variable. So the questions, these questions, where will you use this? Remember that the applications of this one is to show or to prove. So the applications is to prove what? Limit of what? Of the function. So the applications is to prove limit of the function. So this question will ask you that to show that limit as x, y approaches to 0, 0 of what? Of a certain function which is sine of what? Of x square plus y square. X square plus y square over what? Over x square plus y square this is equal to 1. Right? So this is the function and this is the points. So for instance, I'm not going to solve it, but I just want to show you how you can express it by using this formula. Very simple. Then you carry on some procedures. It's not the easy way that if you want to show, but it's possible, right? So the first step for this case, you have to call it formal definition of limit of function of two variables, which state as what? Absolute of f of x comma 0 or f of x comma y, okay, minus limit. This is less than epsilon, okay, and this one implies that we say whenever 0 is less than what? The square root of what of our points, which is x minus a square plus y minus b square, and this is less than what? Delta. Right? So this is the first step. So second step, we say that compare the formula with what? With the given function. So it means that for this case, f of x comma y, it is function. Then the limit L is 1. Then we have what? X, it is x, a, here it is 0. It is 0. Y, it's y. B, it is 0. Then delta remains as delta, and epsilon remains as epsilon, because epsilon, it's a y, it's a small increment in y-axis. And then delta is a small increment in x-axis. Okay, so if you join me, you're only welcome into the lecture, right, of the limit of functions of several variables. And we are focusing on the limits of the function of the two variables, right? So my name is Olenjolai, and I love you so much. And I'm ready here to pour out. I don't know everything about several variable calculus. I just know a small portion of it, but I'm ready. I'm ready, I've been prepared, and this is my habit, it's my tradition, it's my custom to teach other people what I know. I don't know everything. I'm learning every day about new concepts of the several variable calculus because this is my lifetime subject, mathematics. Okay. So if that's the case now, if you compare, now we can have an absolute of f of x comma y, our function which has been given there, the numerator it is sine of x squared plus y squared divided by what? Divided by x squared plus y squared, absolute, right? And then this one will be what? This one not before absolute, according to this formula. This is the function equivalent to this. We have minus L. Limit of our given function is what? Is 1. So we have to subtract this 1. And then we close our absolute sign. And then we say that this one is less than what? Epsilon, right? So because it's less than epsilon, this will implies what? So we say that, okay, we can use that symbol, or we can use the what? That whenever what? Whenever 0 is less than, right? What? Square root. Square root. First of all, it's not this, yes, square root of what? Square root of x minus a square plus y, but a for our case now, it's the first point in this pair, it's 0. Then y minus what? Minus b, right, square. This should be less than delta, right? So simply, we keep on going with the given function that sine of x squared plus y squared, okay? Then this one is x squared plus y squared, okay, minus 1. And then this is less than epsilon, okay? So we say that whenever what? Whenever 0 less than square root of what? Square root of x squared plus y squared, right? Yes, because here we have x, b here it's 0, excuse me. You have x minus 0, it is x. Y minus 0, it's y, right? So this one is less than what? Yeah. So if you can proceed, fine. But it's a little bit challenging to prove or to show. It's not simple like in functions of the single variable. Okay. So I believe that now you have understood the four concepts. Informal definition of the limit of the function of the single variable. Informal definition of the limit of the function of the two variable. Formal definition of the limit of the functions of the single variable. Formal definition of the limit of the functions of the two variables. So now I want to give you just 2 examples. Okay, 2 examples. Should I give you 2 examples? So you have to say, yes, I should give you 2 examples. Yeah, 2 examples, and then I leave the homework for you. Yeah, leave the homework for you. And then we'll meet in tutorial solving, or in problem solving. Okay? So, ladies and gentlemen, allow Sir Olenjolai to present to you the first example of functions of several variable calculus, right? So the question asks you that solve for what? Solve for limit of what? Of x, y. Let us begin with simple examples, and then we'll be going further and further to x minus y squared. Okay? Solve the limit of the function. So maybe you can find that I've written. So I'm about to end this lecture. Okay, so to prepare me. So this is twice x, okay? Twice x minus. Okay, so we have now example 1. We have to solve, means you have to find the limit of the function, which is 2x minus y squared as x, y approaches to 2, 3. So the first step, recall the formula of the formal definitions of the limit of the function of the two variables, right? So we say that, or I told you that limit as x, y approaches to a, b of the function f of x, y, this is equal to r. Interesting. So let me make a point. I remember that I told you that in order for the limits of the function, limit of the function of the two variables to exist, then the conditions has to be obeyed. But that is for the rational functions, because in the rational function, we have a tendency of functions to be undefined. But in case of the linear functions of the two variables like this, we don't apply that concept. We just define the limit of the function directly, right? So you have not this one, not before. We say that for linear function of two variables, okay, the condition for existence of the limit is not applicable. So you remember, because I told you it's not applicable. So for this case, we just go to the second step. Suppose that this is question 2. Suppose that this is question 1. So the second step, so that let us compare the question 1 and the question 2. Okay, question 1 and the question 2. Okay, question 1 and question 2. So in question 1, we say that what do we need? We are interested in A, which is equal to 2. We're interested in B, which is equal to 3, right? And then we're interested in limit, the one that we are finding. We're interested in f of x, y, it's a linear function. Which twice x minus what? Y squared. So the third step, say that let us find what the limit of the given function. So to find limit of the given function, say that you're looking at the limit of as x comma y approaches to what? A comma b, and here a comma b is 2 comma 3 of our given function, which is 2x minus y squared. So you have to find, right? To find, you just substitute in positions where you have x, you just substitute 2. So you have 2 times 2 minus what? So in positions of y, we have 3. So minus 3 squared. So then we say that limit as x comma y approaches to 2 comma 3, okay, of twice x minus y squared. This is equal to what? This is equal to 4 minus 9. And hence this will make negative what? 5. So therefore, limit as x comma y approaches to 2 comma 3. 2 comma 3 of the function twice x minus y squared. This is equal to negative 5. Okay, negative 5. So that's the answer. I made a graph on the line. This is the answer. So as I promised you that I will do 2 examples. So let me take you into another interesting example, which is example 2. And this is concept now. After I'll give you the homework, it will be the end of lecture 3. Then so we'll meet together in lecture 4. Okay, I believe that you won't miss. So the question starts with this one. Let f of x comma y, f of x comma y is equal to sine of x squared plus y squared over x squared plus y squared. Then find limit as x comma y, limit of the function f of x comma y as x comma y approaches to 0 comma 0. Okay, interesting. So that's the problem we have. We have a rational function similar to the one that we used in the formal definition. So we have a function of the 2 variables, which is rational function, numerator, denominator. We have to find the limits as x and y approaches to 0. So under this case, just to begin, if you substitute 0 here, sine of 0 to 0, substitute 0 square plus 0 square, 0 over 0 is undefined. So that's why that we have to find the limit. We have to limit the value of x as we approach 0. We have to limit the value of y as we approach 0, because when we reach to, when x is equal to 0 and y is equal to 0 at the same time, then we find we have undefined functions, a defined value which we don't need in mathematics. Okay? So solution. Okay, the first step always, we say that recall the condition for the limit of 2 variable function to exist. And this I told you that the limit to exist, we said that limit as x approaches to a of the function of x comma 0, this should be equal to the limit as x approaches to b of the function 0 comma y, and this will be equal to limit r. So suppose that this is equation 2, and again allow me to call this one as equation 1. Okay? Question. I believe that you are still enjoying the beauty of higher engineering and scientific mathematics for undergraduate students. Okay, wow. So if this is the case now, we say that we go for the second step. The second step, we say that let us compare what? Question 1 and question 2. Okay, question 1 and 2. So when we compare them, we find that we just need the value of A and the value of B. Value of A is equal to 0, value of B is equal to 0, value of f of x comma y, this is equal to sine of x squared, so the function, it's not the value, and here we have x squared plus y squared. So we have everything that we need to apply this condition to find limit of the function, to check first of all. So you have to check whether the limit exists, right? So steady state, you say that check if limit exists. How do we check that? Okay, first of all, we have to find limit as x approaches to a, which is 0, of f of x comma 0, right? F of x comma 0. And this one to be limit as x approaches to 0. Then we have a rational function. Whenever we have y, we just put 0. So here we have 0 square of what? X square plus what? 0 square. Right? So we continue. So we are looking for the limit as x approaches to a, 0, which means f of x comma 0. So this one, we remain with sine of x square over x square. So many students also, they get confused there. And they get confused because they used to forget stuff. If you reach that stage, what the name of the numerator function? It is what? Trigonometric function, it's a sine function. So sine has properties. And one of the properties that we have in trigonometric functions, sine, cosine, and tangent, is a concept, or is a property called small angle. So you go for the first stage. So if you forget the concept of small angle in this state, then you are completely lost. So say that for the small angle, right? The small angle of what? Of x, we say that sine of angle theta, this is always estimated equal to theta. For that case, sine of x squared, this is estimated as x squared. Interesting. So you find that now we can get the limit of the function of x comma 0 when x approaches to 0. So you say that limit as x approaches to 0, and hence you have a function would be up there f of x comma 0. Hence we say that here we have in numerator now we have x squared, right? Okay, we have x squared. Suppose that this is equation 3. This is equation 3, and this is equation 4, right? So we say that after having this one, so that substitute equation 4 in equation 3. So to substitute it, we say that now limit as x approaches to 0, here we are going to have x squared over x squared. So x squared over x squared is equal to 1. So therefore, limit as x approaches to 0 of our function f of x comma 0, this is equal to 1. Fantastic. You see how high engineering and scientific mathematics is beautiful? Well, so then we go for the fifth state. The fifth state, we have to find it. We have to find limit as y approaches to b of f of x, f of 0, comma 1. Right? So to find it, say limit as y approaches to b, and then we have what? Of functions 0, comma y. This is equal to limit as y approaches to b, which is 0. Then here we have sine of x, but in x we have to replace with 0, plus y squared over 0 squared plus y squared. Right? So for this case, again we say this limit is equal to y as approaches to 0. Then in numerator function we have sine of y squared over y squared. right? So you go again for the small angle. We go again for the small angle, right? So that the 60. Say that for the small angle of sine, the small angle of sine, we say that sine y squared, this is approximately equal to y squared. So limit is equal to what? Limit as y approaches to 0. Then here we have y squared. For y squared, the answer is equal to 1. So the next equation, is this condition satisfied? Yes, because 1 is equal to 1. 1 is equal to 1. So if the condition is satisfied, at the limit of the function. Interesting. At the limit of 40 of the function. So you got the 7th step. Okay? 7th step. We say that limit, so therefore, limit as x approaches to 0 of f of x equals 0, this is equal to limit as y approaches to 0 of f of 0, 1, which is equal to 1. So therefore, limit as x, y approaches to 0, 0 of what? Of our function here, which is sine of x squared plus y squared divided by x squared plus y squared. This one is equal to 1. And that's the response. Then now it's a time for homework 3. And this will be our example 3. We'll be doing some more examples in tutorial of this concept. So the question asks you that evaluate. Just I want to give you a simple question. Evaluate what? Evaluate limit of the certain function, of the function which is 3x. Very simple question. Plus 4y, that's a linear function. Plus 4y. Hence here we have x, y approaches to what? Approaches to 1, negative 1. So evaluate the limit of this function. Very simple. For serious students who have been following me from the beginning to the end, this is a very simple question. Okay, so unfortunately that I'm unhappy that it's the end of lecture 3. But I'll be happy soon because I'm going to start lecture 4, where I'll be teaching about continuity of several of functions of the several variables. And then, you know what will be the lecture 5? Lecture 5 now, I'll be solving questions, tutorial questions, for the limit of the functions of the 2 variables and the continuity of the functions of the 2 variables. Right? So, don't miss it. Stay prepared. Do the homework. Send the solutions of this homework in the comment section. I thank God who have created me in his own image and likeness. And I thank God who loves me so much. And I thank God who have built the gift of teaching in my heart. And I thank God who have given me this great idea to teach present and future generations, national and international students about the Queen of Engineering, which is higher engineering and scientific mathematics. I thank God who have given you an opportunity, because if I could know all of this stuff and then nobody who is learning through them, then it will be meaningless. But now this information is meaningful because I'm transmitting to you and you are receiving to me. Remember that if you want to give God thanks for what he told you, I know that the concept which I've been teaching you are real confusing, and especially that so many lecturers and even professors, they fail to rearrange the contents and even explain the simple language. So I believe that even myself, that I couldn't make it without the help of the Lord, or the help of the Lord, who is my Father, who is in heaven. So the one who prepared me and taught me how to teach you, right? So again, in case you want to give him your free willing sense givings from your heart in order to participate and to support the 500 videos of higher engineering and scientific mathematics to be in air for the present and future generations. Don't hesitate to send your free willing sense giving offering. So it is for number 0759745331, and the confirmation name is Olenjolai TAYAI. That's my name. So thank you very much. I invite you inside lecture 4 when I will teach about continuity of the function of the two variables. Don't miss it. Get prepared, share these contents, solve more questions as well as you can, love the beauty of mathematics, and hence get prepared to solve real life problems. So I will be with you soon. And may God bless you abound. I'm always praying for all my online and physical students. I'm always, in my day and night prayer, I'm praying for you. I ask you also, without the assistance and help of the Lord, I won't do anything in this program. I can mention even millions of the ideas or the millions of the specific objectives, but I can't achieve one of them because without the Lord, I can't do anything else. So I ask you, set a time, 5 minutes, 10 minutes, maybe an hour, 2 hours, 3 hours to pray for me. Because really, this is the great business. I'm doing the work of 12 lectures because I told you that I'm going to teach you 12 modules or 12 courses. It's a work of 12 lecturers, right? Physical lecture, but one man has been called by God to do it. I have nothing else to boast myself. That's the grace of the Lord that's working to me. That's why that I will be capable to teach you all of those 12 courses or modules in a very simplified language, and even that you will keep on loving them. And you'll be unhappy when I tell you that this is the end of certain modules or a certain certain course. Because I know you love mathematics, and if you love mathematics, you don't want to learn mathematics with end. And it's possible for that. Okay? So may God bless you. May God keep you. May God keep you. May God keep you. May God keep you and teach you until we meet in the next lecture.